Welcome to STEM Professionals. In this video, we'll discuss four important things. The first one is converting units. The next one is converting more than one unit at a time. The next one is order of magnitude calculations. And finally, scalars and vectors. So let's start with the video. Now we're going to start with converting units, and this topic is very useful because most of the time we would require to change units. So let's start with an example here. Suppose you need to convert 100 inch to meters, and for that you should know the conversion factor. So 1 inch, it means 2.54 centimeter. Now 1 centimeter means 10 to the power minus 2 meter. So this would be equals to 2.54 times 10 to the power minus 2 meter. So this is the conversion factor, this one, to convert 1 inch to meters. So we need to convert 100 inch to meters. So we're going to write 100 inch as it is. Now we need to convert inch to meters. So 1 inch is equals to 2.54 times 10 to the power minus 2 meter. From here we can write this thing, that 1 inch is equal to this much. Now this inch and this inch will cancel it out, and we are left with meters. So that will be equals to 2.54 times 10 to the power minus 2 times 100. So this would become 1, this thing. So finally we'll get the answer to be 2.54 meter. Therefore we can write that 100 inch, it is equals to 2.54 meter. Now let's take a practical situation. Now you are traveling on a car, and here you see that the distance of a particular place is written in two different units. This is 3 miles, which is equivalent to 5 kilometers, or other way around you can take this one. This is 26 miles, which is nearly equals to 42 kilometers. Now from this example you can understand that how important the unit conversion is. Now next we're going to discuss converting more than one unit at a time. Now suppose you are walking on a street and your speed is 6 miles per hour, and you wish to know your speed in meters per second. So we have to convert miles into meter and hours into second. So we are converting more than one unit at a time. So let's see how we're going to convert this. For that, again you should know the conversion factor. So 1 mile, it is equals to 5280 feet, and 1 meter, it is equals to 3.281 feet. And then hours into second. So 1 hour, it is equals to 3600 second. So these are the conversion factor. Now we can easily convert this thing. So this 6 miles per hour as it is. Now first we're going to convert mile into feet. So 1 mile, it means this much of feet. So 5280 feet. Now feet into meter. So we know that 3.281 feet, this is equals to 1 meter. So we have converted mile into meter, because here we see that this mile and mile will cancel out, and this feet and feet will cancel out. We are left with meter. Now next we can convert hour into second. So we know that 1 hour, it is equals to 3600 seconds. So this hour and this hour will cancel it out. So that will be equals to, on simplification, we will get 6 times 5280. This is 1, so no need to write, divide by, this would be 3.281 times 3600, and this is in meter, so meter over this will be second. Now we can further simplify this and we'll get the result to be 2.68 meter per second. Therefore we have converted 6 miles per hour to meters per second. So this is the way we convert more than one unit at a time. Now next we're going to discuss order of magnitude calculations. Now an order of magnitude calculation is a rough estimation designed to be accurate to within a factor of about 10. Now the aim of such a calculation is to give a roughly idea of what the order of magnitude should be expected from a more complete calculation. So let's understand this concept with a practical example. Now here you can see that this car is running at some speed and the bike is also running at some speed. Now suppose that the speed of car is 250 miles per hour and the speed of bike is suppose 0.007 miles per second, and we need to calculate the ratio of car's speed to bike speed. This thing what we have to calculate. Now roughly 250 miles per hour is roughly equals to 100 meter per second, and 0.007 miles per second, this is roughly equals to 10 meter per second. This is not the exact value, but roughly it is equals to 100 meters per second and 10 meters per second. Now from here we can easily calculate the ratio. So car's speed we have 100 meter per second and bike's speed we have 10 meters per second. So the ratio would be equals to 10. Therefore the car's speed is 10 times more than the speed of bike. So this is the way we calculate a rough estimation, and this method is very useful when we are doing calculations manually. So I hope you are done with the order of magnitude calculation. Now next we're going to discuss scalars and vectors. Now physical quantities are sometimes defined only in terms of a number and the corresponding unit. Like you can take the area of the room to be 20 meters square. Now here 20 is the number, or you could say the magnitude, and meter square is the unit. So this is a scalar quantity. Or you can take temperature. So temperature of the room is suppose 298 Kelvin. So here 298 is the number and K represents the Kelvin, which is a unit. So these are the scalar quantities. So we can write that this one is scalar. So what are vectors now? Now other quantities that require both the numerical value and the direction. So it requires the numerical value, or you could say the magnitude, and also the direction. For example, velocity. Now velocity is a vector quantity, and if you take speed, speed is a scalar quantity because speed doesn't require direction, and velocity means direction plus the magnitude. Now vectors can be in 1D, that is vector in one dimension, or it can be in 2D, that is vector in 2 dimension and vectors in 3 dimension. Now these two topics we'll study in detail in chapter 3. As of now, we're going to discuss the vectors in 1 dimension. So we're going to discuss the vectors in 1D. Now let us understand it with this animated video. Now here you can see that there are two cars. One is traveling in the right side and another one is traveling to the left side. That is, they are moving in the opposite direction. And we are going to indicate the direction of travel with a plus sign for motion to the right and a negative sign for the motion to the left. So this direction we are taking it to be positive and this direction we are taking it to be negative. And suppose that the two cars are traveling at a speed of 30 meters per second. So velocity of car 1 will be equals to plus 30 meters per second. We have taken a plus sign here because it is moving to the right side, and this positive sign denotes that the car is moving to the right side. Now here we're going to write velocity v2 as minus 30 meters per second. Now why we are writing minus? Because it is traveling to the left side. So this is the way we represent vectors in 1D. So whenever we deal with a 1 dimension vector, we shall indicate their direction with appropriate sign. And I have written the statement here that whenever we deal with 1 dimensional vectors, we shall indicate their direction with the appropriate sign. So this is all with this video, and with this the first chapter of the season 1 is over. Next we're going to discuss the questions based on the concept that we studied in chapter 1. So thank you.